Students, we have learnt that a polynomial is an algebraic expression where the powers of the variables are whole numbers. Let's study some examples of polynomials. The expression x square plus 10x plus 15 is a polynomial. The powers of the variables in this expression are 2, 1 and 0 respectively. The constant term 15 can be written as 15 into x raised to 0 because x raised to 0 is equal to 1. Therefore, the power of the variable is 0 here. Now, think about this. Is the algebraic expression 3 upon y square minus 7y is a polynomial? No, because in the term 3 upon y square, the power of y is minus 2. Since minus 2 is not a whole number, the algebraic expression 3 upon y square minus 7y is not a polynomial. Now you have well understood the concept of polynomials. A polynomial in variable x is represented as px. Now let's learn to find the value of a polynomial. When the variable in a polynomial is replaced by a number, we get value of the polynomial for that number. Let's study an example. Suppose px is equal to 3 to x square plus 10x plus 5. Let's find the value of this polynomial for x equal to minus 3. Let's substitute x equal to minus 3 in the polynomial px equal to 3x square plus 10x plus 5. Therefore, p minus 3 is equal to 3 into minus 3 square plus 10 into minus 3 plus 5 equal to 3 into 9 plus minus 30 plus 5 equal to 27 minus 30 plus 5 equal to 2. Therefore, p of minus 3 is equal to 2. Now, let's study one more example. If value of the polynomial y square minus ay plus 14 is 0, then y is equal to minus 2. Find the value of a. Solution: py equal to y square minus ay plus 14 and y is equal to minus 2. Therefore, p of minus 2 is equal to minus 2 square minus a into minus 2 plus 14 equal to 4 plus 2a plus 14 equal to 18 plus 2a. But it is given that p of minus 2 is equal to 0. Therefore, 18 plus 2a equal to 0. 2a equal to minus 18. Therefore, a is equal to minus 18 upon 2. Therefore, a is equal to minus 9. Now, you must have well understood the concept value of a polynomial. Now, let's study the remainder theorem. When the polynomial p of x is divided by x plus a, the remainder is p of minus a. In other words, the value obtained by substituting x is equal to minus a in the polynomial p of x is the remainder when p of x is divided by x plus a. Let's study with an example. Suppose we need to find the remainder when the polynomial p of x is equal to 3 into x square minus 2x minus 5 is divided by x plus 2. Here we can find the remainder using various methods of division. Let's use synthetic division to find the remainder. P of x is equal to 3 into x square minus 2x minus 5. Therefore, coefficient from p of x is 3, minus 2 and minus 5. Divisor polynomial is x plus 2. Opposite of 2 is minus 2. Let's solve this using synthetic division. Now, a vertical line and a horizontal line are drawn. The left side of the vertical line is labeled with minus 2. In the first line above the horizontal line, the coefficients of the dividend polynomial are written as 3, minus 2 and minus 5. In the third line below the horizontal line, the first coefficient of the dividend polynomial 3 is written as it is. The multiplication of 3 from the third line and minus 2 from the divisor gives minus 6, which is written in the second line, below the minus 2 coefficient. Then the sum of minus 2 and minus 6, which is minus 8, is written below in the third line. The multiplication of minus 8 from the third line and minus 2 from the divisor gives 16, which is written below minus 5 in the second line. The sum of minus 5 and 16, which is 11, is written below in the third line. 11 is the remainder of this division. 3, minus 8 is the coefficient from the quotient. Coefficient from the quotient is 3 minus 8. Therefore, quotient is equal to 3x minus 8 and remainder is 11. Now, let's carry out the division by usual method. 3x square minus 2x minus 5 divided by x plus 2. First, let's multiply by 3x, which gives us 3x square plus 6x. After subtraction, we get minus 8x. Let's take minus 5 from above. Now, let's multiply by minus 8, which gives us minus 8x minus 16. After the subtraction, we get remainder as 11. Therefore, the quotient is 3x minus 8 and remainder will be 11. Now, let's find the value of p of x is equal to 3x square minus 2x minus 5 when x is equal to minus 2. Let's substitute x is equal to minus 2 in p of x equal to 3x square minus 2x minus 5. Therefore, p of minus 2 is equal to 3 into minus 2 square minus 2 into minus 2 minus 5 equal to 12 plus 4 minus 5 equal to 11. Therefore, when x is equal to minus 2, the value of p of x is 11. Thus, the remainder obtained when the polynomial p of x is equal to 3 into x square minus 2x minus 5 is divided by x plus 2 and the value of p of x when x is equal to minus 2 are same. Here we have verified the remainder theorem. We can say that for any real number a, if the polynomial p of x is divided by x plus a, then the remainder is p of minus a, which is the value of the polynomial p of x for x is equal to minus a. Now, using the remainder theorem, let's find the remainder when the polynomial m cube minus 3m square plus 4m minus 7 is divided by m minus 1. Solution. Given polynomial is p of m equal to m cube minus 3m square plus 4m minus 7. This is the dividend. M minus 1 is the divisor. Therefore, let's substitute m is equal to 1 in the given polynomial. According to the remainder theorem, remainder that is p of 1 is equal to 1 cube minus 3 into 1 square plus 4 into 1 minus 7 equal to 1 minus 3 plus 4 minus 7 equal to minus 5. Therefore, when the polynomial m cube minus 3m square plus 4m minus 7 is divided by m minus 1, remainder is minus 5. Now, you have understood very well how to use the remainder theorem. Let's solve this example for practice. When the polynomial 2y cube minus ky plus 16 is divided by y plus 2, the remainder is 8. Find the value of k. Solution. P of y is equal to 2 into y cube minus ky plus 16 is the dividend. Y plus 2 is the divisor. Let's substitute y equal to minus 2 in the given polynomial. Therefore, p of minus 2 is equal to 2 into minus 2 cube minus k into minus 2 plus 16 equal to 2 into minus 8 minus k into minus 2 plus 16 equal to minus 16 plus 2k plus 16 equal to 2k, equation 1. But p of minus 2 is equal to 8 because it is given that the remainder is 8. Therefore, according to the remainder theorem, 2k is equal to 8 from equation 1. Therefore, k is equal to 4. Now, you have understood the value of a polynomial and the remainder theorem very well. Practice more examples based on these concepts. What did we learn? For finding the value of a polynomial for a given value of the variable, the given value is substituted in place of the variable in each term of the polynomial, and then the value of the polynomial is calculated. Remainder theorem. If p of x is a polynomial and a is a real number, then the remainder obtained when p of x is divided by x plus a is equal to p of minus a. Exercise. Find the value of the polynomial x cube minus 4x square plus 3x minus 9 using the given values for x equal to 1, x equal to minus 1 and x equal to 2. Using the remainder theorem, find the remainder when the polynomial y cube minus 9y square plus 27y minus 36 is divided by y minus 3. Verify your answer by the synthetic division method.